Good morning, grade 7. Today we are going to start to explain lesson 2 with the title The Periodic Table. But before knowing the explanation of the periodic table and the classification of elements, we have to know that there are 4 types of elements. How many types of elements? 4. The first type is called metal. When we look at the figure or the electronic configuration that we explained in the last session, we can find that any metal, the outermost energy level ended with 1 or 2 or 3 electrons, while the non-metal, the second type of elements, is non-metal. All non-metals have the outermost energy level 5, 6 or 7 electrons. The third type of element is called metalloids, and metalloids in grade 7 means they are elements that have the properties of metals and also the properties of non-metals. And we can I can tell you the names of these metalloids with their symbols because you have to keep all of it. The fourth type of elements is called metalloids, as we said, and also the inert gases. So there are 4 types of elements: metals that ended with 1 or 2 or 3 electrons in their outermost energy level, non-metals that ended with 5, 6 or 7 electrons in their outermost energy level, metalloids, number 3, the metalloids that have the properties of metals and also the non-metals, and the last type is called the inert gas or inactive gases that their outermost energy level are always completely filled with the electrons. They completely filled with 8 except the helium, which is saturated by 2 electrons. The second part of the lesson talks about the attempts of classification of elements in the periodic table. The first periodic table, the real one, that is made by a scientist called Mendeleev. And Mendeleev arranged the elements according to their atomic weight or even the atomic mass, ascendingly from the left to the right, in horizontal rows, and he called these rows after that with a scientific name called period, and also arranged the elements according to their physical and chemical properties so we can facilitate their study. And also he discovered in his table that the properties of elements repeated at the beginning of each new period. So if I look at period 1, I can see the lithium period 2, period 3, sodium, period 3, calcium or potassium. So I can find that the properties of sodium and lithium and potassium are similar in their chemical properties. Actually, in their outermost energy level that's saturated with electrons. After Mendeleev, there is Rutherford. Rutherford discovered what in grade 7? Discovered that the nucleus has positive protons, as we drew yesterday in the last session. And then after Rutherford, we have Moseley. And Moseley in his table rearranged the elements according to their atomic number, not to their atomic weight or not to their atomic mass. So he arranged the elements according to their atomic number, also ascendingly from the left to the right, in which each element increases its atomic number by 1 from the element that precedes it. Yani if I have lithium 3, so after lithium we have beryllium 4, we have boron 5, we have carbon 6, and so on. So each element, its atomic number increases by 1 from the element that precedes it in his table. Also, Moseley added the 0 group or 18 group or inert gases or inactive gases. All these names are the names for the 0 group, which contains 6 inert gases, and you have to keep the names of these elements: helium, neon, argon, krypton, xenon, and radon. These are the inactive gases that all with their outermost energy level completely filled with electrons, with 8 electrons, except the helium that is saturated by 2, as we distributed it in the last session. Then the modern periodic table. The modern periodic table is done by a group of scientists, or a group of the scientists participate in the modern periodic table, in which they rearrange the elements according to their also atomic number ascendingly from the left to the right in the horizontal rows, or we can call them as periods, and also according to the method of filling energy sublevels with electrons. As we said, each mean energy level has a certain number of sublevels. So in the modern periodic table, he arranged the elements according to the way of filling energy sublevels with electrons, and also according to the atomic number ascendingly. So if I want to summarize the attempts of classification of elements to facilitate the elements study: number one, Mendeleev according to atomic mass. Number two, Moseley according to atomic number ascendingly. Number three, the modern periodic table according to the atomic number ascendingly, and also the way of filling energy sublevels with electrons. The second part of the lesson talks about the description of the modern periodic table. When we look at this table in grade 7, we can find that it consists of 7 horizontal periods, or 7 horizontal rows. These rows are called periods. So we have period 1, period 2 starting with lithium, period 3 starting with sodium, 4, 5, 6, 7, according to the number of the main energy levels and the heaviest atom, which is 7. And also it consists of 18 vertical columns, and these columns are called groups. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, ending with 18 group. This is the modern number, while the traditional number starting with 1, 2, till we reach to the 0 group. It contains 118 elements. These are found in nature around us, and some of them are prepared artificially in the lab, like the radioactive elements. And also, these elements are classified, as we said at the beginning of the session: metals, non-metals, metalloids, and inert gases. Some of these elements may be solid, and the solid may be metal, like sodium or potassium, or non-metal, like phosphorus and sulfur. May be liquid, and the only liquid metallic element is mercury, while the only liquid non-metallic element is bromine. Also may be gas, and there are active gases like oxygen, nitrogen, hydrogen, or maybe inactive gases like neon, helium, argon, krypton, and radon. It consists of 4 blocks: S block, P block, D block, and F block. Again, S block, it takes the first 2 groups. P block, starting from 3A to the 0 group. D group, that is located in the middle of the table, and finally the F block. Let's start with the S block. When we look at the S block, we can find that it's located at the left side of the modern periodic table, and it consists of 2 groups. They take the letter A, 1A and 2A. 1A, these elements are called alkali metals, except the hydrogen. This is the only non-metallic active gases that found in 1A. And the configuration of the alkali metals, their outermost energy level contain 1 electron. Then 2A, the 2A, their names are alkaline earth metal. They are metals that less active than the alkali metal. And the 2A here means that it contains 2 electrons in their outermost energy level, like magnesium 12, 2, 8, 2, like calcium 20, 2, 8, 8, 2, which means that their outermost energy level ended with 2 electrons. Then the P block, as we see, the P block here is starting from 3A, 4A, 5A, 6A, 7A, and 0 group. I cannot say here 8A. There is no group called with 8A, but it's called 0 group, or even 18 group, or the group of inert gases, or the group of inactive gases. All these names are right for the 0 group. The B block grade 7 consists of 6 groups from 3A to 0. The B block contains less active metals like aluminium, 13, 2A3, contains metalloids, and we say the metalloids are elements that have the properties of metals and also the properties of non-metals. And contains 7A, which is halogens, called what? Halogens. And 7A means that their outermost energy level contain 7 electrons. Ended with the inert gases that are completely filled with 8 electrons, except the helium that's situated with 2 electrons. So we can find that inside the P block there are metals like aluminium, there are non-metals like oxygen, nitrogen, there are halogens which are iodine, bromine, chlorine, fluorine. Also we have the inert gases. What are the metalloids here? There are 6 metalloids and also you have to keep all of them. So we have 6 inert gases and also 6 metalloids. The 6 metalloids are boron, silicon, germanium, arsenic, antimony, and tellurium. You have to keep the names and the symbols for the metalloids. What about the inert gases? Also, they are 6 inert gases, starting with helium, neon, argon, krypton, xenon, and radon. That's for P block. Starting with the D block. D block, as we see, it's located in the middle of the modern periodic table. It is starting to appear from period 4, and this note is very important. The D block is appeared from the period 4. It contains the transition elements, and it consists of 10 groups. So again, the 6 block, S block has 2 groups. The B block has 6 groups, while the D block has 10 groups. They take the letter B, starting from 3B, 4B, 5B, 6B, 7B, and 8 here has 3 columns or 3 groups, and ended with 1B and 2B. And finally, in grade 7, we have the F block. And as we see, the F block grade 7 is located below the modern periodic table or below the S, P, and D block. Its real place inside the D block, but the scientists put it below the table to relieve their eyes while they are studying the elements. It contains 2 series of lanthanides and series of actinides, lanthanides and actinides. So, grade 7, if I want to compare between 1A, 2A, 7A, and 0 group, according to the names of the elements, number 1A called alkali metal, 2A alkaline earth, 7A called halogens, and 0 group called inert gases. 1A ended with 1 electron in their outermost energy level, like lithium, sodium, potassium. 2A ended with 2 electrons, like magnesium and calcium. 7A ended with 7 electrons in their outermost energy level, and 18 completely filled with 8, except the helium, which is saturated with 2 electrons. 1A and 2A contain metals, the very active metals. 7A halogens, non-metal, and 18 contain the inert gases. So today, in grade 7, we talked about what? We talked about the description of the modern periodic table. Let's answer some questions in the booklet as we always do. How many elements are located in the first period? Period 1. Period 1, we have helium and hydrogen. So how many elements are located in period 1? 2 elements. Now, what about the period 2? Period 2 is starting from the lithium and ended with the neon. So lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, then the fluorine and the neon, 10. So we have 8 elements in the period 2. And the same way to calculate the number of elements in period 3 and period 4. The second question that we have here, compare between 1A and 2A according to the name of the group. We said 1A is called excellent alkali metals, while 2A is called alkaline earth metals. Okay, what about the number of electrons that are located in the outermost energy level? In potassium, we know that the potassium located in 1A, in S block, in 1A. And because it's located in 1A, so the last energy level must contain 1 electron. So I will write here 1 electron. 1 electron. What about the calcium? I know that the calcium, it's located in 2A, S block, but 2A. And we said that the 2A means it contains that 2 electrons. So I will write 2 electrons in its outermost energy level. If I want to make sure that these answers are right, I know that the atomic number of potassium is 19. Now let's distribute it in energy level. K, L, M, N. Let's distribute the 19 as we said in the last session. 2, 8, 8, 1. So the outermost energy level or the last energy level contain 1 electron. So my answer is right. What about the calcium? I want to make sure that it contains 2 electrons. Its atomic number is 20. Let's distribute it. 2, 8, 8, 2, right? So the last energy level contains 2 electrons. So my answer here is also right. So today in grade 7, we talked about the types of elements, which are metals, non-metals, metalloids, and inert gases. Then we talked about the description of the modern periodic table, which consists of 7 periods and 18 groups. We talked about the blocks S, P, D, F, and the properties, the elements, the number of groups inside each block. Don't forget the attempts of classifying elements, starting with Mendeleev according to the atomic mass, mostly according to the atomic number, and the modern periodic table according to the atomic number, and the way of filling energy sublevels with electrons. Then we learned how can we predict the number of electrons in the outermost energy level according to the group or the blocks that they are located in it or belong to it. Just answer different questions about this part and study hard. With best wishes, thank you for your listening and I wish you a good day. Bye bye.